Hello friends, once again I welcome you to our ongoing journey on Six Sigma, and today we are discussing lecture 27, that is non-normal process capability analysis. We have devoted 3 lectures process capability analysis for normal, and we had seen the first lecture, the concepts related to process capability, what is its need, what does it tell, and what are the various cases, 3 cases when my process is meeting, barely meeting the specifications, my process is barely capable, rather my process is not capable, and my process is adequately capable. And then we have seen the various indices, and followed by that we have seen the application of Minitab for conducting, say, process capability analysis for normal data. This lecture 27 will help you to understand what is non-normal process capability, when it should be conducted, how it should be carried out, and how we can use the Minitab to easily conduct this non-normal process capability analysis. So, once again I would like to remind, a bad system will beat a good person every time. So, correct the system first. So, we have seen this, that what is the use of Minitab, how it can be conducted. There is 6-pack process capability analysis, and there is simple capability analysis, and what are the outputs it can generate and how to interpret these outputs. This particular lecture 27 will focus on process capability revisit, just a small example. What is non-normality? Transformations of non-normal data. What are the ways you can conduct the process capability analysis, and Minitab application with illustration. So, if we just revisit our concept with an example, let us say there is an intensive care unit lab process, has an average turnaround time of 26.2 minutes and standard deviation 1.35 minutes. The nominal value for this service is 25 minutes with an upper specification 30 minutes and lower specification 25 minutes and 20 minutes. The administrator of the lab wants to have 3 sigma performance for her lab, and is the lab process capable of this level of performance? That is the issue that I want to investigate. Now, you have upper specification limit USL 30, LSL 20, average service 26.2 and sigma 1.35 minutes. So, I will just plug in the values into my expression for CPK, and it basically takes the minimum of x double bar minus lower specification divided by 3s and upper specification minus x double bar divided by 3s. So, computing this, I get CPK minimum of 1.53 and 0.94. So, I will take 0.94. So, this is my process capability index. I would also like to find the CP, which basically measures the spread and variability of the process. So, USL minus LSL divided by 6 sigma, and I get 1.23. So, here I can say that does not meet 3 sigma, which is typically 1 CPK target due to shift in mean, and if we note here, then variability part is okay, CP is okay, it is greater than 1, but my CPK has a problem, and typically my CPK value is my CPK value here is 0.94. So, little bit less, we have the standard that it should be around 1.2, 1.3 or at least 1, and in this case my variability is okay, CP is okay, but there is a shift in mean, and hence my CPK has some problem. So, you have the upper specification 30, lower specification 20, average service 26.2, sigma is 1.35, CPK 0.94, CP is 1.23 before any modification. Now, you need to take the corrective action short term or long term. As I mentioned, short term you can just shift the mean and try to avoid producing the scrap, that will give you the cost saving, but this is just the short term temporary measure. For long term you try to replace the part, set the process, develop the skill of the operator and see that your process can remain at a particular targeted value for a long operation period of time. Now, let us talk about the non-normality in the data, which is the focus of this particular lecture. So, CPK is an index which is many a times misused. Remember that this index is only applicable to normally distributed variable data, and this is typically measured for short term. Capability studies for non-normal data, let us say Weibull distribution, do not give CPK values, and if you will just try to fit, let us say this non-normal data and try to figure out or find out the values of CP and CPK, then it would be misguiding, misleading. So, my assumption about the normality of the data must be checked first, and then only the question of process capability analysis comes. If the data is non-normal, you must conduct the non-normal process capability analysis. If it is normal, then you go for normal process capability analysis. So, now the question is that if I have the data non-normal, or if I have to check rather my data is normal or not normal, then how will I check? So, there is a procedure and that can help us to check whether my data is normal or not normal, non-normal, and what to do. So, if data is non-normal, how to perform process capability analysis, that is the second question. So, you will just struck your head and think that now my data is not normal, what to do. So, if data is non-normal, it does not follow typically the normal pattern. When you look at the histogram or normality plot, then how to perform is a question. So, here I would recommend that there are two options possible. Option number 1, find the best fit distribution. Let us say your data fits to exponential, chi-square, Weibull, and perform directly the process capability analysis in Minitab under capability analysis non-normal. So, this provision is there, but for that you need to figure out that what is the best fit distribution for your data. If you do not want to do this, the option 2 is to transform your data which is non-normal into normal using some kind of transformation, mathematical transformation, and then perform the process capability analysis with the simple normal data assumption, and you can get the same result both way, either option 1 or option 2. So, let us try to see that how to execute different options. So, option 1, find the best fit distribution and perform the process capability analysis. So, I am interested in finding the best fit distribution. It may be exponential, Weibull, triangle, whatever. I want to see that my data fits best fit to which particular distribution. So, if data is non-normal, then how to find the distribution? So, you can use Minitab very easily to do this exercise and choose the strat quality tools, individual distribution identification, specify the column of data to analyze, and from the distribution drop down menu in the main dialog, you can choose the various distributions to compare with, and then your Minitab will give you the best fit for various distribution comparing, and you can find out that which distribution your data basically is resembling. So, process capability for non-normal data, once you have figured out your non-normal distribution, best fit distribution, then directly go to the option capability analysis non-normal, perform it, and you will get the results. So, option 2 is basically to transform. Now, when I cannot do the regular capability analysis which is meant for normal data, and if my data is non-normal, I have to transform the data. This is option 2. So, you have the non-normal data and try to make it more normal by transforming it through some mathematical function. So, you can first check through histogram or your normal probability plot that whether your data is normal or not, and if you feel confident that yes, my histogram as well as normal probability plot indicates that my data is not normal, then you transform the data. So, you have two options to transform the data, two transformations rather. One is Box-Cox transformation, other is the Johnson's transformation. It is extremely difficult to do it manually. I will give you the mathematical expression for your understanding, but we take the help of software which has inbuilt function, mathematical function, and that helps us to transform the data very easily. So, Box-Cox transformation, the critical element here is the lambda, which raises the power of the data to that extent where your data becomes more normal. So, just see the expression that yi raised to lambda is equal to yi raised to lambda minus 1 divided by lambda for lambda not equal to 0, and if you have lambda equal to 0, then yi raised to lambda is equal to log yi. So, lambda typically is a random variable and software packages are typically used to calculate the lambda, and y is basically your observed data point, typically your data which is non-normal, and this lambda will help you to transform your non-normal yi data into more normal. So, you have a certain inference on the transformation parameter. So, the main objective of Box-Cox transformation model is to make inference on the transformation parameter, the critical parameter lambda, and Box-Cox in 1964, this particular method was proposed. He advocated two approaches. Number one is to use the maximum likelihood method. You may have to read little bit on this, and the second approach is to use the Bayesian approach and considering the previous data, posterior distribution, and you can little bit read on this to just get familiarized with this terminology. So, you have another option that is Johnson's transformation, and the Johnson's transformation typically plot the z value, your normal critical value versus p value, that is the probability value for each of the three Johnson distributions. So, he has given a typical family of three distributions SB, SU and SL. So, descriptive statistics of original and transformed data including Anderson-Darling statistics, which basically checks the normality of the data and the associated p value. So, histogram of the original data and the transformed data can also be compared for visual purpose, and you can have the PP plot which typically say compares your empirical distribution function and theoretical cumulative distribution function. So, empirical distribution is based on the sample, how your events are occurring, and the theoretical distribution is based on the large data set available. So, we try to compare these two and see that to what extent my transformation is acceptable. So, you have Johnson's transformation, typically it differs from Box-Cox, and the difference is that it tries to select the function from three different Johnson families SB, SU, SL, and the selected function is then used to transform the original data. In case of Box-Cox, that transformation component was lambda, here you have 3 distribution families and typically it does not assume the data in subgroups. So, you have typically this Johnson transformation families, which is SB, B stands for bounded, L stands for log normal and U stands for unbounded. So, bounded is something of finite size and this is the case if it is smaller than other object that has a finite size, otherwise it is unbounded. So, you can see the expression, mathematical expression, and as I mentioned that it is difficult to do it manually, it is always better to use the software, but obviously we should appreciate the logic behind. The software has basically created a platform and using it. So, you have SB, which is typically expressed in terms of a transformation function lambda plus eta log x minus zeta divided by lambda plus zeta minus x, and same way you have SL and SU. So, I am not going into the details of these mathematical expressions, but I would like to make a mention that depending upon your nature of data, it will select one of these mathematical function and transform the data to the more normal data. So, let us try to see how we can conduct this analysis, that is non-normal process capability in Minitab. I have highlighted here 2 sources from which you can learn this application into greater detail. I have also used them for explaining this application to you. So, illustrative example 1, let us say I have the Minitab software and typically I need to follow the steps like this. Consider typically a Lean Six Sigma project to reduce the lead time required to install typically an information technology solution at a customer site, and it should take no more than 30 days. So, working is for 10 hours per day, Monday, Friday to complete, Monday to Friday, and test and certify the installation. So, following the standard process, the target lead time should be 24 days and I need to conduct the non-normal process capability to see that to what extent I am capable enough to meet this target. So, 24 days may be the target, but we know that customer satisfaction increases if we complete the installation faster, and we basically need to understand or figure out that our baseline capability to meet that demand, what is it, so we can perform a capability analysis. Now, just see this and you would find that your distribution is positively skewed and it does not have the normal distribution pattern of the data, and I have to conduct the non-normal process capability analysis. So, steps are very simple to follow. You collect the data, identify the shape of the distribution. So, for that step 2 you go to stat, basic statistics, normality test. So, I am showing you the window also so that you get clear idea about executing the non-normal process capability in Minitab. So, you have this particular window where you have percentile lines. So, I am saying none. You have the variable of interest, I am putting lead time. Test for normality, I am selecting Anderson-Darling. So, I would like to just mention here, when we would be discussing the various tests in the subsequent lectures, statistics is the tool by which, inferential statistics, by which I can check my hypothesis, I can check my claim at certain level of significance and say that okay, my assumption or my claim is true or it is false. So, when I want to do this with certain kind of assumption, then there are various tests available. For this purpose, I would use the Anderson-Darling test, which is widely used to check the normality. So, in lecture 1, I clearly mentioned that to learn this course you need to have as a prerequisite some basic knowledge of the statistics. Anyhow, we are discussing the important concepts, but it is always desirable that you have some knowledge about the basics of the statistics, including distribution and probability theory and other. So, that part you should keep in mind. Now, let us see that what is the next step in my analysis using Minitab. So, I can see here very clearly that my normal probability plot shows that my data is not fitting the straight line, then my assumption about normality of the data is not valid. It means my data is non-normal. You can also check the p-value. We have not discussed the concept of p-value so far, but you can just see that your p-value is 0.005, which is quite less than the level of significance. You might have assumed 0.05, and hence it is in the rejection region. We will see this in the subsequent lecture, how to test the hypothesis. And again, this inferential measure indicates that my assumption about normality is not true and my data is non-normal. Now, step 3, verify the stability. So, typically in Lean Six Sigma project which we are trying to study for installation of the software, I have a data set, but I would like to check the stability through individual moving average chart, and this will tell me that over a period of time my process is in the statistical control or not. If not, then there is no point in conducting the process capability analysis, whether normal or not normal, for the collected data. So, I can do this very easily in the Minitab. I am putting the variable lead time. I can generate this chart, already I have shown in the previous slide, and I can see that yes, there are some of the points which are falling outside and there is a stability issue. So, either I can discard this point and do it again, or I can take certain corrective actions to see that my process becomes statistically controlled and stable, so that whatever data I collect that are adequate and good enough to conduct the process capability analysis. Now, I have the observation that these data points which are indicated outside the upper control limit, they indicate the abnormal variation, and once identified, resolve the cause of these points. As I said, take the corrective action, and you can take the additional data or remove the data points from the data set, and then you can conduct the process capability analysis for the remaining data. Step 4, what non-normal distribution does the data best fit? So, as I mentioned, you have two options available. Option number 1, you can find out what is the best fit distribution and directly use the option for non-normal process capability in Minitab and conduct the analysis, or else you can transform the data to normal and then you use the normal, say, process capability analysis in Minitab. So, both it a way it is okay. So, here I am just trying to see that what could be the best fit distribution, and I am trying to do it with the option 1. So, just see this, that my variable of interest is lead time, subgroup size I have considered 1, and I am trying to select the various distributions normal, exponential, Weibull, gamma, and my, say, output will help me to understand what is the best fit distribution. So, here Minitab will give the output for the 4 graphs typically shown in this slide, and what you can see here that exponential on my probability plot, exponential the data best fits. Also you can verify this here, that Anderson-Darling value is 0.514, which is quite acceptable. We have not discussed this test in detail, so leave it, but you can at least refer the p value 0.481. So this is greater than the alpha, which is 0.05 in this case, and it is acceptable. So visually also it is acceptable, as well as statistically also it is acceptable, and in all other cases if you see, then p value as well as Anderson-Darling value, they do not conform. And if I look at the probability plot, again it is not conforming, that my data is fitting to that particular distribution. So here my data best fits to the exponential distribution, and fine, I can conduct the non-normal process capability choosing the exponential distribution. So you can also compare it with the other distribution and just check it the best fit, just check for other distribution. So no way it is meeting, just visually you can see the probability plot and you can figure out that it is not fitting that particular distribution. So now step 5, what is the process capability? So you use the options stat, quality stat tools, capability analysis, non-normal. I am exercising option 1 because it is my non-normal process capability. I have figured out what is the best fit distribution. So you have chosen here this exponential distribution, which you found in the previous analysis, and now with this you conduct basically the process capability analysis. So you put the target value, you put the k value, that is your tolerance k into sigma. So 6 sigma, let us say capability strats pp percent, and you try to find out the various values. So you will see here that PPU is 0.23, PPK is 0.23. So my process is not capable to meet the required specifications or my target of completing a project, and there is a need to improve upon my implementation plan. I have included another example, you can quickly go through this, but the same procedure is applied. I have the data set describing the customer to be they are greeted by a salesperson and how long this process takes. So usually customer is greeted very quickly, and if you keep customer waiting and then you greet, then it will lose the value of greeting and welcoming. So this is the data I have, and this data set you can use in fact to conduct the analysis as a hands-on exercise. I have given here the USL, this is the upper specification limit for our process, and within 6 minutes it should be done, and there is no lower specification. As early as possible, the moment customer comes, you greet, welcome him, and let us say you have the data given in your table 1. So open this window, enter the data, choose this normality test. First let me check whether my data is normal or not normal. I will get this probability plot, clearly I can see it is not normal. Then I can check the stability. I will see that couple of points are falling outside, indicated in red. So take the corrective action, remove this point, consider the other points, go to stat, quality tool, individual distribution, conduct the analysis. Again I can see that my best fit distribution here is exponential. So I would consider this as the best fit distribution for conducting my process capability analysis. So then you put the, consider the exponential, define the variable in column, upper specification, there is lower specification 0, immediately you can greet welcome the customer. You will get the analysis which says PP is lower than 1, not acceptable, PPL is just 1, both PPU and PPK are less than 1. So, the sales people or the people at the desk, they are not very well trained, or the rush of customer is very high. I need to really correct my process of greeting, welcoming the customer, so that can give customer a better satisfaction. So, this is the capability analysis 6-pack that will also help you to understand the capability of your process, but output will give you 6 different say display in one window, and R chart, I chart, stability of the process, then observation plotted over a period of time, is there a trend exist, and then normality through histogram as well as best fit distribution, and then process capability indices. Let me just end this session with a small think it. What is non-normal process capability and what is the non-normality in the data, and what are the procedures you would like to follow to convert your non-normal data into the normal data? What is Box-Cox transformation, why this model is used, and what is Johnson transformation function, how it helps in finding out the process capability in Six Sigma processes. You can use these references which has given the details of non-normal process capability, but I would insist that you use the same data or some other data and have hands-on exercise in Minitab, so that you feel confident in conducting as well as interpreting the results of non-normal process capability analysis. So, CPK is an index misused, only use it when the data is normal. Otherwise, convert your data non-normal into normal or choose the best fit distribution, automatically your software will take care and it will convert it into normal and give you the best result, appropriate result of the process capability. So, thank you very much. Keep revising, be with me, enjoy.